NASA's plan is to build a base on the moon before sending humans to Mars, so the process of reaching Mars becomes shorter. SpaceX founder Elon Musk wants to win the race to reach Mars. Besides this, European and Russian space agencies also talk about sending humans to Mars. But how will humans survive after landing in Mars' harsh atmosphere? Because unlike Earth, the most vital element for life, oxygen, does not exist on Mars. What method has NASA developed to produce oxygen on Mars, and why won't the method used by the International Space Station (ISS) work on Mars? Once again, welcome to Discover TV's videos, viewers. There are many reasons behind humanity's desire to live on Mars. Scientific exploration and space curiosity are factors, of course, but among these desires lies a necessity or fear, the fear that some disaster on Earth might wipe out the human race, just like the extinction of dinosaurs 65 million years ago. And this is entirely possible, as we can see an example of it on Earth in the form of climate change. This is perhaps the biggest reason why, in the coming times, someone will become the Neil Armstrong of Mars. On one side, Elon Musk initially aimed to colonize Mars by 2026, but now he has predicted 2029, slightly pushing back the expected date to put the first human on Mars. So let's see how we have built a production system for making oxygen. On the other side, NASA has also planned to land humans on Mars by 2030. But the real question isn't who will get there first. The real question is, how will humans survive on Mars? Certainly, many of Mars' properties are similar to Earth's. For instance, a Martian day, also called a sol, is only 39 minutes longer than an Earth day. There are different seasons on Mars too. Earth has ice caps at its poles, and so does Mars. Earth has an atmosphere, and although thin, Mars has one too. But one thing that makes Mars completely inadequate for human habitation is the lack of oxygen. So, how will oxygen be produced on Mars? Not just for one or two people, but to sustain an entire colony. When it comes to keeping humans alive in extreme situations, the first thing that comes to mind is the ISS, International Space Station. It has spent 25 years in the harsh conditions of space and continues to provide oxygen and fresh water to astronauts. There are always 4 to 5 astronauts on the ISS who require at least 45 liters of water daily. That's 1,350 liters monthly and 16,200 liters yearly. In addition, the ISS uses about 1,000 kilograms of oxygen gas annually. How is so much water and oxygen made in space, 400 kilometers away from Earth? For this, the ISS is equipped with 2 systems, the Water Reclamation System (WRS) and the Oxygen Generation System (OGS). To understand why these can't be installed on Mars, we must first understand how these systems work. The WRS collects water from human waste, urine, sweat, and humidity, then purifies it and makes it drinkable again. Astronaut Douglas V. Locke once said, "Tomorrow's coffee is made from today's coffee." The WRS purifies the existing water on the ISS, making it reusable and saving 98% of water from being wasted. Parallel to this is the Oxygen Generation System. It takes a bit of water from the WRS, processes it, and produces breathable oxygen. This simple process is called electrolysis, which we learned in 5th grade. By passing an electric current through water, it is split into oxygen and hydrogen gases. The oxygen is used for breathing, but hydrogen is a highly flammable and dangerous gas that can turn the ISS into a fireball within seconds. This hydrogen is not wasted, it is fed into another system called the Sabatier system. This system collects waste carbon dioxide from astronauts and combines it with hydrogen to produce water, methane gas, and some heat. The water is reused, the heat goes into a thermal management system, but the methane, which is a valuable fuel on Earth, is released into space because burning it requires oxygen, which is the most precious resource on the ISS. If we closely examine the ISS's entire oxygen and water process, it depends on refueling missions. Despite being 98% efficient, losses and leakages occur, so every 6 months or year, water and oxygen are brought from Earth to the ISS. These refueling missions are extremely costly. Just sending 1 liter of water for 100 kilometers above Earth costs over $10,000. So, producing oxygen on Mars minus to 125 million kilometers away using the same method would not be cost-effective. We need a system that can produce oxygen using resources available directly on Mars. In 2021, NASA sent the Perseverance rover to Mars, equipped with a device for this very experiment called MOXIE, Mars Oxygen In Situ Resource Utilization Experiment. Since the ISS gets water through refueling, but Mars would require us to extract ice by either going to the polar caps or drilling deep into the ground, MOXIE uses Mars' atmosphere, which contains 95% carbon dioxide, to generate oxygen. To explain in simple terms, MOXIE pumps carbon dioxide from the Martian atmosphere, pressurizes it, and then heats it in an electrolyzer at 800 degrees Celsius, which separates oxygen gas from carbon dioxide. This electrolyzer is made of gold because gold is an excellent heat conductor and protects other components from heat damage. This process also produces carbon monoxide alongside oxygen. The problem is that if carbon separates completely, it can form a layer much like what forms at the bottom of a cooking pan, and this layer could damage the furnace. That's why the process is performed with great care. But how much oxygen does MOXIE produce at one time? The process requires a huge amount of energy, which is why NASA only operates it occasionally when extra solar energy is available. So far, it has produced just 122 grams of oxygen, enough to keep one person alive for only 35 hours. To produce more oxygen on Mars, a larger version of MOXIE and a powerful energy source would be required, and that is the biggest challenge so far. Here's the key point. MOXIE compresses carbon dioxide using a compressor, then heats it to 800 degrees Celsius. Both steps require massive energy. To solve this, scientists are working on future technology that can break down carbon dioxide molecules at lower temperatures, not by heating, but by inducing vibration in the molecules to separate the oxygen. Currently, this technology has only been tested in labs. But due to Earth's high atmospheric pressure and temperature, this experiment can't be done here. Mars' atmosphere, however, is perfect for it. No matter the technology, our goal is to produce oxygen on Mars using only local resources, and the devices that make this oxygen should not depend on Earth. The ISS is only 400 kilometers from Earth. If its oxygen system fails, astronauts can wear emergency suits, wait a few hours for refueling, or return to Earth. But on Mars, after colonization, if the oxygen generation system fails, there will be no refueling option, and returning to Earth won't be easy either. We hope you'll like and share this Discover TV video as well. Thank you very much for your kind comments. See you in the next amazing video.